Hello Year 12, welcome to the first video here for trig functions. Okay, now during this topic we're going to learn, first of all we're going to learn a little bit about radians and some stuff with sectors and arc lengths and segments. But mostly what we're going to be looking at here are trig functions, sine, cos, tan, sec, cosec, cot, and particular sine and cos. Right, we're particularly interested in those. If we're to really boil it down to the nub of this whole topic, is we want to differentiate and integrate sine and cos as much as anything else. Righto, but we're going to begin with radians. Instead of using degrees, right, instead of 360 degrees to a revolution, we're going to describe this angle in radians, using radians, where the angle is going to be equal to the arc length divided by the radius of that arc. Okay, so if I have some arc length here, this is my arc length, L, that's my radius, and that's theta, right? So if I do the length of this curve here divided by the radius, I get the angle measured in radians. Of course, if I was to have the full circle, then the circumference would be 2 pi r. If I divide that by r, I just get 2 pi. So 360 degrees is equivalent to 2 pi. 180 degrees is pi. 90 degrees, pi over 2. Okay. We can pretty quickly come up with some conversions here from degrees to radians and radians to degrees. We'll try to stick with its exact terms where we can. So 5 pi over 4, I want to express it in degrees. 5 pi over 4. I'm going to multiply that by 180 over pi. Right, my pi's cancel out. The 4 cancels with the 180 to give me 45. And 545 is 225. Rightio? 225 degrees. Now, of course, 5 pi over 4 is a little bit more than 1 pi, right? 4 pi over 4 would be 1 pi, so I know it's a little bit more than a straight angle, a little bit more than 180 degrees. That works out nicely for me. Now, here we go. I've got degrees, minutes, seconds. I want to convert this to radians. I'm going to have to pull out the calculator here. I'm not going to get an exact answer. So, here's my calculator. As promised. Right, and I want to convert this, so I'm going to need to multiply it by pi over 180. So what I'm going to do first is my 132 degrees. Didn't work. 22. Again, look, you keep pressing that button. It still looks like degrees, but that's fine. 10. Rightio, I've got this. What I'm going to do first is divide that by 180. Equals this. I'm going to convert that to a decimal. It's that many pi. Let's multiply that by pi. So my answer is, stop doing that to me. So my answer is 2.310 for significant figures. Equals 2.310 for significant figures. Doesn't have units, right? Because this is a length divided by a length, it's a ratio, right? There are no units to that. 2.310. Wonderful. Next up here, evaluating trig functions, special values. I know we've talked about this in class a little bit, and this really is a recap of things you've done before, but a reminder. If I want to find the exact value for some values, right, that are related to, that's all I can really say for now, 30, 45, 60 degrees. So this is going to be pi on 6, pi on 4, pi on 3, right, as well as 0 and pi on 2. Right, we need to know some of these. The two triangles, the two right angle triangles that you'd be familiar with for using these are on your formula sheet. Okay, the 0 and 90 degrees, the 0 and pi over 2 radians stuff, we're going to have to remember a bit. Okay, so I think we've probably got an example here. Yeah, here we go. I want to simplify this expression. So I need, neither of these are acute angles. 4 pi over 3, right? Not an acute angle. 11 pi over 6, not an acute angle. So let's draw a little sketch first. X and Y. 4 pi over 3, right? It's more than 1. It's less than 1.5. Right? It's here in the third quadrant. 4 pi over 3, and in fact, I reckon it is about here. Right. That's my 4 pi over 3. Now AST, so this is going to be equal to the negative. Now I need always to measure my angle back to the horizontal, the acute angle to the horizontal. Now, how much more than pi is this thing? Well, it's pi on 3 more than pi, right? Because this is like pi over 3 plus 3 pi over 3, right? So this is pi on 3. So I need the negative sign of pi over 3 here, and that's the top. Right, remember, everything's positive, sine is positive, tan is positive, cos is positive. Now let's look at the second one here, 11 pi over 6. Well, that's only 1 pi over 6 short of 12 pi over 6 short of 2 pi. So that is over here. Right. That angle there is pi over 6. And ASTC, cos is positive there, so this is equal to the cos of pi over 6. Now it probably helps here to have this little thing going on, where I've got 1, 2, root 3. Now this is pi over 6, pi over 3. So sine of pi over 3, opposite on hypotenuse, root 3 on 2. So I've got negative root 3 over 2 all over. Now the cos of pi over 6 is adjacent on hypotenuse, is root 3 over 2. Right. Now divide by a fraction, I multiply by the reciprocal, right? I'm going to multiply root 3 over 2 by 2 over root 3. It all cancels out to give me an answer of -1. Rightio. So that these things do simplify down really nicely. You've got to use these angles of any magnitude. Now one more little thing here for this first video, as long as it is we can solve trigonometric equations too. The periodic nature of trig functions mean that we get multiple answers, but we are going to choose typically answers between 0 and 2 pi unless stated otherwise. We will see there's a regular pattern of them. Now, cos of x equals negative root 3 on 2. Well, for cos to be negative, it needs to be second and third quadrant. Okay, so I'm looking for solutions in the second and third quadrant. Now, root 3 over 2 is pi over 6. So I need pi over 6. I need, an acute angle of pi over 6 here in the second quadrant. It's pi over 6 here, so it's 5 pi over 6 here. Right? Let's draw that again. Right, the negative tells me I'm in these two quadrants. The root 3 over 2, looking back here, root 3 and 2. Right, cos is this one in between. So it's pi over 6 here. So that's pi over 6. That means this angle here must be 5 pi over 6 to make it up to full pi for a straight angle. So I could say that I've got this one and I've also got this one here. Right, so x equals 5 pi over 6, or this one 6 over 6 plus another one, or 7 pi over 6, right? Because cos is negative in the second and third quadrants, right? I've got a negative answer, so that x must be over here somewhere. There are two different values it could be, right? To get the root 3 on 2, I need an angle of pi over 6, so it's pi over 6 less than pi over 6 more than pi, right, to fall into those quadrants. Good. Now, one more and we are done for this video. Tan x equals 4. Now, I know well enough that's not one of my exact values. Right, all I can do here is say that. Now, tan is positive in the first and the third, okay? It's going to be first and third. Whatever my answer is here, I can add 180 degrees to it, okay? Because you can think about tan is like the gradient of a line. If you think this line underneath is the same gradient as this line continuing through on the other side, right? It's only sort of their direction. There's 180 degrees difference, or pi difference between those. So I need to pull out my calculator here and say x is the inverse tan of 4. In fact, it's going to be fairly steep up here. It's going to look like this. So I think the answer is going to be a little bit less than pi over 2, right? It's going to be a little bit less than 90 degrees, not too much less. Now pi over 2 is about 1.5, so I think an answer of about 1.2, 1.3 sounds sensible to me. Okay, all clear. The inverse tan, right, second function tan of 4 equals, right, see what's happened here, 75, that's not what I'm after. I want radians. Here's a reminder, set your calculator to radians. Okay, be aware of that. Clear it, we need to put in radians. So we're going to change the setup, second function mode. Right, see option here, 4 radians. 4. Now when I do inverse tan of 4, there's my answer, the 1.3 that I was hoping for. Okay, so that is approximately equal to 1.326. And if we were to go, right, so that's my 1.326. Right, if we were to go all the way around to 2 pi, I would have another option, which is that plus pi. So let's pull out my calculator again. 1.326 plus, oh no, let's not do that. Answer equals, there we go, plus my pi gives me 4.467. Right, yeah. Now the question should specifically say within what range, because if I added another pi onto that, and I say what's the tan of 7.777 or whatever it is, I'm going to get 4 again. 7.77. It does sound look. Oops, all clear. Right, we'll just see if that's approximately true. Tan of 7. Don't know. I made a mistake there. What about if we just confirm our answer here? Hang on. Wow, it's a little bit off there for a moment because I thought, oh, well, I can roughly add pi on here. But because it's very steep around there, you've only got to be out by a little bit, quite a different answer, closer to 7.6. Right, and you keep typing in the 10 of those things, you get 4. There are an infinite many solutions if I don't put bounds on these. So typically your questions will. Otherwise, it's probably not going to hurt to give your answers between 0 and 2 pi. Rightio, that's the first video. What we've looked at is what radians are, how to calculate them, how to convert between degrees and radians, and how to express some exact values using radians. See you in the next one.